Hey there, welcome back to the Parkinson's Disease Education Podcast. Now, you may have heard this before, but I want you to humor me for just a minute. What if we could protect or even potentially repair dopamine neurons in Parkinson's disease instead of just throwing dopamine at the problem, via medication, in other words? Now, I know that sounds too good to be true, and a lot of treatments that will be talked about and have been talked about on this channel and others may have similar kind of predictions or similar hopes. But there's one I want to discuss with you today that may have that promise or it may not. We'll see by the time we get to the end of this episode. In this episode, we're specifically going to be discussing FGF-1, which is also known as Fibroblast Growth Factor-1, which is what FGF-1 stands for. It's a molecule that's getting attention right now in regenerative medicine, particularly recently in Parkinson's disease. Prior to this, you may not have heard of this molecule or this growth factor. I want to discuss that with you with a little bit more detail today and to let you know about what's going on in research as we speak. I wanted to cover this episode because I've heard people ask about it on the channel. I've seen people share some information about it in limited form. You yourself may have seen some promotion of this. I've heard the phrase neurorestorative therapy kind of circling around FGF-1. So in this episode, I hope to break down what FGF-1 is, why it could be a potentially exciting area of research for Parkinson's, and what the actual science says about this restorative nature of the FGF-1, particularly as it pertains to Parkinson's. So without further ado, let's go into the episode. Cue the intro. I'll see you on the other side. Welcome to the Parkinson's Disease Education Show, where we demystify the disease and empower you as the person with Parkinson's disease to reach your true potential. The content contained on this show is for informational purposes only and is not meant to be a replacement for information or advice that you receive from your in-person medical or therapy professionals. If you haven't already, I hope you'll consider subscribing, and for an even more personalized experience, please ask us about our memberships. Now, without further ado, let's start the show. So as I mentioned in the open, FGF-1 stands for Fibroblast Growth Factor-1, and it's among a group of molecules that the body uses to help to regenerate certain parts of the body. So fibroblasts in particular are cells that produce things like collagen, for example. It's proteins that are naturally found in the body, and among other functions that can help regulate things like cell growth, blood vessel formation, tissue repair, wound healing, and angiogenesis, which is basically the same thing as blood vessel formation. That would be arteries. So in the brain in particular, growth factors are important for neuron survival, for the ability of synapses in the brain to change over time, so the ability to form new pathways essentially, and repair after injury. There's other growth factors we've discussed here on this channel and podcast before, such as GDNF, glial-derived neurotrophic factor, and BDNF, brain-derived neurotrophic factor. In that light, this has some potential similarities to that in terms of if we can improve FGF-1 activation, proliferation, whatever, can that help to restore areas of damage of the brain? Again, to repeat, the FGF-1 is not dopamine. It doesn't help to replace dopamine or any other chemical, but it could potentially help with things like we mentioned with, in terms of neurons, helping cell survival. So in other words, helping to prevent cell death, improving blood flow in the brain, reducing inflammation in the brain, especially with the disease process that's ongoing with Parkinson's, and possibly stimulating neuroprotection to keep existing neurons from damage and death. At least that's the theory that we're working with. So going back to why in Parkinson's specifically that this may be targeted, it's because in Parkinson's we see a lot of progressive loss of neurons, which is an obvious reason. Parkinson's disease tends to progress. The continuation of dopamine-producing neurons dying off results in a deficit of dopamine and a domino effect that just keeps going. There's a lot of neuroinflammation in Parkinson's. A lot of it's been linked with oxidative stress and mitochondrial damage and dysfunction, and also reduced neurotrophic support, meaning some of those factors we mentioned earlier, like GDNF, BDNF, there may be not a sufficient amount of those to help protect the neurons in the brain from premature cell death. But as it pertains to FGF-1, if we can increase, meaning science, if we can help to stimulate more growth factor signaling, more production and release of this growth factor, in theory, maybe we could protect dopamine-producing neurons that remain, keep them from further damage, improve the environment around the existing neurons that are damaged, possibly slow the progression. Now, at this point, the only studies that exist, similarly to other treatment techniques that we've discussed on the podcast, are in preclinical studies, meaning these are animal models, not humans. So any results, even positive ones, have to be taken with hesitation, not hesitation, but with some degree of caution, because we don't know that it's going to have the same results in people. But that being said, FGF signaling may reduce oxidative stress, as shown in animal models. It may promote angiogenesis or improved blood supply because of new growth of blood vessels in the area in question, and also supporting neuron survival pathways. But again, animal or laboratory models don't guarantee similar or the same results in humans, so we just have to tread lightly on this. As of this recording, there are no large randomized placebo-controlled phase 3 trials, that would be like the biggest, most evidence-based versions of clinical research being conducted. None of those exist at this point, proving FGF-1 reverses Parkinson's. Not really sure if it shows that it even helps, but the point is it doesn't reverse Parkinson's, or certainly doesn't cure Parkinson's. Data in humans is very limited at this point in history. Some small or experimental studies exist, and in fact, some of the ones that exist, like the Zetia trial, again, it's a small individual trial, and parts of it have to be self-funded. In other words, it's not like a governmental sponsored or even privately backed sponsored research where you get the study is paid for. All you have to do is participate in the research. Some of this requires travel, and a lot of expensive travel and lodging to be a part of this trial. That's just one example, but that's one of the ones I know of that's the most talked about in online circles these days. Also, some of the clinics that are offering FGF-1 based treatments are outside of FDA approval, at least in the US, that's the case. So, to summarize all that, FGF-1 isn't FDA approved for Parkinson's. It is not a disease-modifying therapy at this point in time, a proven neurorestorative intervention. But we've seen this before. If you remember my episode where I discussed reversing Parkinson's with the fast walking protocols, I'll leave a link in the top right screen for that. The trials that have previously been done on things like GDNF, glial-derived neurotrophic factor, those initial trials generated some excitement. Even groups like Cure Parkinson's in the UK have backed some studies on this, some big ones. But there's promising early signals, but translation to humans compared to animal models, again, with that case is also very difficult. And measuring GDNF in a living human's brain is very difficult. It's not something that you can just take a quick scan of the brain, or take a quick blood test. There's nothing that's like super concrete that you can really study with it. I think, if I remember correctly with the GDNF, it was really related to essentially brain mass and differences in brain mass between individuals. So just to go into some risk factors, if you do decide to become a part of one of these trials or to try the treatment of some kind, you need to just be aware of the fact that growth factors of any kind stimulate cell growth. So you could potentially or theoretically be introducing a situation where you have abnormal cell growth in your body, which abnormal cell growth of any kind is either a tumor or it's cancerous. That's not a good thing. So in other words, it could affect unwanted tissues that you don't want growth in, promote abnormal cell proliferation, meaning that's usually like hyperplasia, where it's a normal cell, but it's overdeveloping, or at worst, it's some kind of benign tumor or whatever. Again, it increases cancer risk, which is theoretical, but it definitely is a plausible theory. The second thing to consider is the delivery of treatment. So how is it administered? Is it intranasal, intravenous? Is it intrathecal? Intrathecal, by the way, that refers to an area called the intrathecal sac, which basically surrounds the brain and spinal cord. essentially from those connective tissue protective layers, the meninges. You have to get through or near the meninges to have any kind of injection, whether or even something like a spinal tap has to be done in those areas, and there's a risk for infection like meningitis when you puncture that area. Or is it something like an implanted pump that's like just under the skin? Crossing the blood-brain barrier is a major hurdle with any of these types of materials we're trying to get into the brain tissue. So I would say that's something else to consider in weighing potential risk-benefit analysis. The third thing is cost. Some of these clinics, the regenerative clinics of the private ones, they're charging people thousands to tens of thousands of dollars out of your pocket. This is most big trials are, again, they're self-funded. They're either funded by grants from the federal government or private donors or both. And you, as the participant, typically don't have to pay a dime to be a part of it. I find it very suspect that anybody is charging thousands or tens of thousands of dollars to be a part of a treatment, let alone a trial. But I think this is more treatment. This is more for treatment versus trials, but still, big risks involved in spending that kind of money. But often these are not, again, covered by insurance, so you're going to be out the whole bill. It's not FDA regulated. Again, there's no oversight whatsoever to determine safety, efficacy, or any of the above. And also, again, not supported by large-scale evidence. We only have preclinical evidence, and it's not even that strong. It doesn't mean that it won't work. It doesn't mean that it can't work, but it means we simply just don't know yet. So in final summary, and just the key takeaways here, is that FGF-1 is a biologically plausible method of treating. The mechanism does make sense, which is what makes it a plausible theory. And the preclinical data that we do have from the animal models is interesting. Interesting does not equal proven, and it doesn't equal success. So for now, it should be considered FGF-1, that is, should be considered experimental in terms of Parkinson's. It should be something considered more for an early stage individual versus, so-called mid to late stage Parkinson's, and not a standard of care. If you're considering this kind of a treatment, definitely ask to see peer-reviewed data. You want to see research behind these treatments to know that there's ironclad evidence that it could benefit you. Ask about published human trials versus preclinical trials that don't involve human species. Ask about the risk factors and ask about regulatory oversight, because if nobody has any oversight, I'm not talking about drug companies, I just mean, the whatever entity in your country oversees medications and science and research. If there's no oversight whatsoever, and it's only based on the companies doing the research, there's a big moral temptation, especially to alter data in their favor. So if there's no oversight whatsoever, you need to be extremely cautious. And also be cautious of any claims to reverse Parkinson's, of language surrounding a cure for Parkinson's, or testimonials that don't have any controlled data to back them up. We simply are in a world where you cannot just trust things at face value. And even as much as you desire for improvements in symptoms and or a cure, you just can't let that desire or hope replace being cautious and realistic. And of course, Parkinson's desperately needs these disease-modifying treatments, and again, we're working on that in the scientific world. Growth factors like FGF-1 are scientifically intriguing, but we have to hold that excitement and evidence at the same time. So we have to have something to back that hope and excitement. Science moves forward, but it moves carefully, which of course is a very good thing. And that's for everybody's benefit. That's probably all that really needs to be said about FGF-1. I'll leave links in the description and or show notes to the trial that's ongoing with FGF-1 right now, the ZETIA trial. At least give you some things to look up and see what's currently out there. But let me know if you are interested in this treatment, or somehow if you've been involved in it. I don't think that's going to be the case for the majority of people watching and listening, but I'd love to hear from you if that's the case. As always, I hope this was helpful, informative, and interesting to you. Leave a comment below letting me know what you think. And if you haven't subscribed to the channel already, I hope you will. It doesn't cost a thing, and it only helps us to share information like this to the Parkinson's community at large all over the world. To best support the channel, please consider visiting the sites of our sponsors found in the description and show notes below, and or channel memberships. Any of that always helps us to support the work that we're doing. Otherwise, I appreciate you being here, watching, sharing, listening, and coming back for the next episode. Looking forward to that. And as always, be empowered.